I'm Nikolai, CEO and co-founder at Karoot, and today I'm going to talk about observability. And a few words about me. I work for Karoot. We built an open source observability platform, and we try to focus on turning telemetry data into answers, like actionable insights and so on. And I noticed that a lot of other speakers, when talking about observability, are focused on storage, particular platforms, and how to gather data for troubleshooting and how to store them. But almost nobody talks about how to use all this data to find answers. And today I'll try to focus on this particular question. And let's start from the very beginning. What is observability? In simple words, observability is being able to answer questions about your systems. When you deploy your applications into production environment, you should be able to answer these questions like how the app is performing right now. Are there any failed requests and why they fail? And other question can be related to latency and so on. And why do we need answer these questions? The first one, we should be able to provide to make our system available for users, because if you run your business that based on website or mobile app, your application can make money only if it's available for users. Like, to be honest, having all that observability stuff doesn't guarantee you 100% availability, but every bad situations happens in production, so you should be ready to mitigate these issues. The second one reason is, like, you should keep your application performance as high as possible, because lower application latency means better conversions, and it's like good for business. And the last one is costs. As more performant your application, you can spend less money on your cloud costs, and optimizing application can lead to like reducing your cloud cost. And like these days, all problems start from the data. We try to collect data, then analyze it, and make some conclusions. And in case of observability, it's the same. We need to, before everything, we need to talk about data. And let's start from really simple example. We have a trivial web application, Hello World, and we deployed it in production, and we know nothing about its performance because it is not instrumented with any logging, tracing metrics. And let's think about how we should look at this application in production. We have some questions, and let's start thinking how to improve our application to make it observable. The most obvious way to add some observability is add logging, because we can, from our code, we can add few lines and write anything we want to a journal, and to be able to see application performance, the number of requests, their latency, and so on. So logging, from my perspective, is the simplest way to make your application observable. But we have few, we can log everything we want, but it's not without its costs. It's pretty expensive to store and analyze logs on scale. And the second limitation is that you cannot analyze the really intensive log stream in real time. We need some processing, because our brain is not able to read 100 messages per second, and that's why to understand what's happening using logs, you need some processing to make it more understandable. Like we can transform our logs into metrics. Metrics, from my perspective, are some aggregations on raw events. When you have 3 events in your log, you can calculate the count of them, and you will have metrics events per second, for example, and you can make a chart, and it's easy to read. But on the other hand, at this point, when we aggregated our events, we lost the ability to see the particular events. This is the primary metrics limitation. And working with metrics is much more cheap than logs and traces. And we understand how to work with them. We can build dashboards, we can set up some alerting rules, and it's super easy. And the third one, observability signal, is traces. So traces is some events that grouped by some trace ID. It means you can gather all the data that are relevant to the particular request and see the whole picture, or how, for example, a particular user request has been processed through the system. Here is like sample request trace. We see the duration of each stage. We see services involved into processing this particular request. We see errors, and it's like super cool. It makes your application workflow more visible. But traces are, as logs, more expensive comparing to metrics, for example, and you should find the balance. Usually it is done by adding sampling, when you store only the fraction of all your data. And the fourth telemetry signal is profiles. Profiles can help you understand precise to the particular line of code why at this point of time your application consumed more CPU time or more memory as usual. Usually you could see, usually profiles are presented as flame graphs, where wider area means more resource consumption. In this case, we can select some area on the chart and understand functions and calls in our code responsible for this consumption. Or you can compare some CPU usage or memory usage spike with the baseline previous period and understand what was changed. My co-founder, Peter Zaitsev, asked his network on what is the most important pillar of observability. And the majority of people answered like metrics, because everyone knows how to work with metrics. From my perspective, the correct answers is you need all of them. And next we will see why. But before, let's talk about how we gather all that telemetry data. There are really quickly, we have a standard de facto way to instrument our applications with OpenTelemetry as the car. OpenTelemetry is a vendor-neutral product that provides you with SDKs for many programming languages, Java, .NET, everything, almost everything. It supports gathering metrics, log traces, and now they started to add profiles into their supported signals. But it requires some changes in your code. In some platforms like Java, you can just add the agent, and all your code will be instrumented automatically. But like in languages like Go, you need to import the relevant SDK and redeploy your applications into production. An alternative method to gather telemetry data is eBPF. eBPF is a feature of the Linux kernel that allows you to run small programs in kernel space and instrument various kernel space or user space function calls. Especially Corut actively uses eBPF to provide users with zero instrumentation experience. When you set up the agents and that's it, it provides you with insights in minutes. And in case of eBPF, Linux kernel provides some guarantees that there will be not high, like it will not affect your application latency because it has the complexity limit. It ensures that every eBPF program should be super optimized for performance. And the third source of telemetry data is infrastructure metrics and database metrics, because we run our applications on nodes. We use networks for app-to-app communications. We also use databases to store our data, and we should also gather all the relevant metrics, logs, and sometimes traces to understand the performance of network databases and our infrastructure. And the most interesting part of my talk is what we can do with all that data, because it's like pretty easy to collect a lot of data, but we need to figure out how to extract answers. And this is the biggest, from my perspective, the biggest challenge in the observability space. Our approach at Corut is we built a model of each system, distributed system. We understand the applications, their instances, nodes they run on, and we understand how they communicate with each other. And we, as engineers, we start from an overview of the system and how it performs. And then we traverse dependency graph and analyze the performance of each component, and we understand where the problem comes from. Then, if you have to deal with hundreds or even thousands of services, you should add some automation, because it's no longer possible to handle it manually. So let's start from an overview. I believe that every troubleshooting process should start from metrics related to user experience, because it's like the most important metrics in your system. We should check them before we think about nodes, CPU usage, or network issues. We should understand is there any issues affecting our users or not. And for an overview, the better to use traces and metrics, because like logs and profiles are almost useless in this case. And let's look at some examples. Here we have tracing, aggregated tracing view. Each point on this chart is some number of requests. They are distributed over time, and they are grouped by their latency. And also we have the red points that sign that there are some errors. We can select this area and understand that we have some errors in our system, and we can ask the system analyze only error traces and group them by the origin error. And in this case, we can see that product catalog service affected all that requests. Then we can see some latency anomaly. We can see that there are a number of requests that were handled longer than usual. In some anomaly, we can select these slow requests and understand which service call caused this situation. In this case, it's because of we slowed down network between some service and its Redis database. Pretty easy, but we can understand the state of our application using only one chart. It's like we just picked the right representation of all our data. But we cannot use only traces to understand what's happening with our application right now, because in case of traces, you will see only like errors or spans that took longer than usual. But tracing data cannot answer questions like why the application performs slower than before. For example, tracing cannot cover issues related to Java garbage collector activity or some internal PostgreSQL log contention or something else. So, and the second limitation is that you cannot instrument all your application stack because of third-party services, legacy services, and so on. So, and this is why we need not only tracing data, but we should look at metrics, logs, and so on. Okay, let's assume that we understood that now we have an open issue that's affecting our users. We need to somehow understand how our components communicate with each other, and then we can drill down into any particular service and troubleshoot it. Here is a service map. We at Karoot use eBPF to understand communication between between services, understand latency between them, understand network performance between them, and we can easily understand how our components communicate with each other. And thanks to eBPF, it can be done without any blind spots, because you don't need to instrument your applications to have this service map. And using this service map, you can drill down into any particular application and see only metrics related to this one application, its clients, its dependency services like the database, and we can analyze each subsystem separately to understand other issues, CPU-related issues, memory-related issues, and so on. And we use this approach to make troubleshooting easier, because we don't have to navigate through the countless dashboards and so on. And what we should know about each component. I believe that over 80% of application issues are the same. So we can cover the most common pitfalls and highlight them automatically. In our case, for about every application, we know its service level indicators such as errors and application latency. We understand CPU consumption, memory consumption, all resource consumptions. In some cases, we can drill down into runtime environments like JVM environments, .NET runtime. We see all the relevant nodes that host our application instances. We understand connections in all dependency services, so we can traverse the graph and find that like this application is performing slowly because its database performing slowly. We also can track network latency issues, network connectivity issues, and so on. And finally, we have logs of every applications, or we can drill down into CPU profiles, for example. And here we have some predefined inspections. about each subsystem of each application. So we can easily highlight the issues, so you don't need to analyze each chart manually. So here is basic SLO inspection. We expect that our application will serve over 99% of requests without errors, and we expect some latency. It's like adjustable parameters, but this is the most valuable metrics of each application. So, and we should alert only on SLO violations. So until application is not violating its SLOs, we should not care about CPU usage on the relevant nodes or something. Then we should check that we have enough application instances up and running. So we ask Karoot tracks that we have over 75 available application instances. And also we track application restarts, because each restart can affect in-flight requests. So we can have application errors because of restarts. Then we analyze CPU usage, like not only node CPU usage, but also container CPU usage, comparing to its limit, and highlight situations where application has experienced the lack of CPU time. Then we track memory leaks and activity of the OM killer. If our application were terminated by the OM killer because of reaching CPU limit or reaching node memory capacity, we can easily understand that it was restarted by the application, by the OM killer. And also, when we look at the particular application, we see only the relevant nodes, so we don't need to check one node by node. We don't have to remember the mapping applications node, and it works also for dynamic environments such as Kubernetes. Then we can track all communications of each application with dependency services. We can measure network latency between them. We can track failed TCP connections. We can see any network partitioning. So we can easily understand that these two services could not communicate with each other because of network issues. Then we can see all DNS requests by each application. So if something goes wrong and application cannot resolve its database URL, we can easily identify such scenarios. And the most valuable thing is that, as you remember, I mentioned that we need some post-processing for logs to be able to quickly understand what's happening. And Karoot has super interesting features. It can extract repeated patterns from log. So we have a lot of events here, but Karoot understood that there are only 5 types of errors. They group the similar messages and allows you in seconds understand what's happening. Like if we have new type of errors, you will see here spike of errors and quickly understand its type, and then you can jump into samples and see the particular line log lines. Then, as I mentioned, we can drill down into application runtime. In case of Java, Karoot can track stop the world pauses caused by garbage collector or other reasons. But it's super valuable when you think of it when somebody already analyzed all application subsystems and highlighted which application subsystems needs your attention. So in this case, if everything is okay with your JVM metrics, you don't have to look at this, and it's getting drastically save time needed to understand what's happening. And the last one, inspection, is Karoot can track application rollouts and compare new application release performance with the previous one. It's super helpful when you deploy many times a day. So, and you don't have to check metrics every time when you roll a new version out. So Kahoot can, in the background, check every release and notify if a new version has some issues, or it's like there are new type of errors in the logs. And having such automation allows us to sort our services by their severity of like issues. For example, if some services violate their SLOs, we can highlight them. If some services has errors in their logs, we can highlight it. We can not show you dashboards with like beautiful charts, but we provide you with answers about where is the problem. For example, in this case, we can see that there is no available instances of this application. You don't need to navigate to the particular dashboard to understand this. And few words about alerts. Alerts is you need alerts to be able to understand that something goes wrong, and without like when you not look at your dashboards. Like our approach is that we should alert only on SLO violations, and we should not alert you on infrastructure problems or some errors in the logs, because if application is performing as expected, we don't need to dig into any underlying problems, because it's not necessary. It doesn't, like in any distributed system, not unavailability is an expected behavior. So, and we believe that it's not important to track that stuff until your applications are meeting their SLOs. And we try to provide you with rich alerts, which means we know that this application is violating its SLOs, but we know that there are some relevant errors in the logs, or at the same time, the application has network issues. And we can send you a single alert with all this data. So you don't need to analyze it manually or correlate many alerts to understand what's happening. And it's like I almost done, but it's like some summary of my talk. I want you to think about observability, because in DevOps philosophy, we should understand that developers should understand how their applications run in production. I want to highlight that I believe that observability is not about storing your telemetry data or compressing your telemetry data. It's more about understanding your data and being able to extract answers and actionable insights. And I want you to give a try to Kahoot, because it's like open source, free of charge, and you can use it, and you will have all these practices out of the box. And I believe Kahoot can identify over 80% of issues automatically, and like reuse observability as you reuse your code. So that's it. If you have any questions.